Hello everyone. Um, so today we had this glitch in the morning, and because of which our Hangout got stuck up, unfortunately, because it was having some technical error or whatever. Anyways, progressing to finishing the session. Let's start with it first of all. So basically, this is hot streaming replication in Postgres version 9.3. This is going to be brought to you by Ashnik. And today's session will be run by Sameer Kumar, who is our DBA and also a certified PostgreSQL trainer. Who is Ashnik? Well, we are basically an enterprise open source company. We are based in Singapore. We also have presence in UK, US, and India. And more importantly, we are the master partner of Enterprise DB for Southeast Asia region. So we offer Postgres services in this region and beyond. That's a little bit about us. Over to Sameer. Would you like to start the session, Sameer?
Hello everyone. Good morning, good afternoon, good evening guys. Depends on from where you are joining. We know that this video will be watched over and over again and again for a few times. And like Deepthi said, we are sorry about whatever happened in the morning, but we really could not have avoided that. It's just one of the things that happen when you rely on technology. But well, here we are, and let's start with our discussion on hot streaming replication and what new things have come in hot streaming replication in version 9.3, and how these things are going to help you ease the setup, the switchover, and rebuilding the masters in version 9.3. So for people who are new to PostgreSQL, and for those as well who are using a version older than version 9.0, I would like to spend some time and discuss what is actually hot streaming replication. So hot streaming replication is a feature which was added in version 9.0, and that is why I emphasized people who are using it, who are using Postgres older than 9.0. So they probably have not yet used it, but what they would have used is file-based replication or archive-based replication. This hot streaming is a step ahead of that. Here you can replicate the wall xlog records itself to the standby server, and it can be done continuously. So the advantage that it brings to the table is you don't need to set up archiving in advance to make use of this feature, which is really cool, and that is one of the reasons why I love this great feature of PostgreSQL. Now there are some other great features as well, like it is inbuilt into PostgreSQL, like the previous or already existing archiving or archive-based replication feature. It is built in, and you just have to set up certain commands or certain parameters, and then you are ready to go. And we will probably see a demo as well, which will explain you how easy it is, and you don't need a separate tool. It can support multiple standbys, and these standbys could be cascaded. So you can replicate from master to slave, and then again to another slave. So it could be cascaded. Then you can set it up as synchronous replication or as asynchronous replication, and which makes it really flexible enough. These these standbys which are being created using, or which are put into recovery mode using streaming replication, could be hot standby as well, and that is why I would use the term hot streaming sometimes, which would mean that it is just the same streaming replication. It is just that the hot standby is being used as the standby is being used as hot standby, which means it can be used for your read queries, and you can use pgpool for distributing these read queries among your master and the hot standby server. Now let us look at some of the great features which came up in version 9.3. So the first feature, which I became a total fan of this feature the moment I read about it, because I have done this mistake so many times that I will take a backup of a primary server, I will restore it on a secondary server, and after that I will start up the server, and it will take me a few minutes, sometimes 10-15 minutes of time to figure out why the replication is not working. And then I'll realize, hey, I never configured a recovery.conf. So what I do is I have to take the whole backup again, which is really painful, because the moment I start my second server as a standalone primary, the timeline would have changed, and then I can't just add it as a secondary database or a slave database or a replica. So PG based backup now comes with a -r switch, which can help you create a default recovery.conf. Isn't that cool? That makes your whole setup just one process, just one step process, right? Then the second advantage, or the second great feature which you will find in version 9.3 is with respect to timeline switches. Timeline switch is something which occurs whenever a slave becomes a master, and this information so far was only getting captured in the archives, and hence if you have a master replicating to a slave and second slave as well, and one of these slaves becomes master, the second slave has to be rebuilt, or you need to apply archives, because timeline information was not recorded in WAL files and hence it was never replicated. But 9.3 onwards, that information is now recorded in WAL files and it will get replicated as well, and your other slaves will get to know who is the new master, and they will also apply the same timeline switch. So hardly anything needed for remastering, just a restart. Well, we will cover that in detail, how you do that. Then third very critical thing, which is probably not a tangible feature, but which is very important, a great thing which has come up, is whenever you do a smart or fast shutdown, in addition to your data blocks being flushed, what additional thing will happen is X logs will also get replicated. Any transaction which has committed thus far or so far will also get replicated to the secondary servers or standby servers before your primary will be shut down or will be brought down completely, which means that you don't lose any transactions when you shut down your primary in a smart way or in a fast way. So this is great for your switchovers, and you don't have to really rebuild your masters in that case. If you're doing a smart switchover, what will happen is everything will get replicated to the slave, and when you bring back your primary, again the old primary, you can add it as a slave, and that slave will receive the timeline information or the timeline switch information as well, because of the second great feature that we discussed. So let's just go ahead and see how you can set up a replica and how easy it is to set up a replica. To do that, in your labs or on your local server, of course, the first thing that you need to do is install Postgres. If you have not done that already, install it on both primary and secondary database servers. But if you're gonna just use the same database server for this testing purpose, or just to try out this feature, you don't have to install really it on two servers. Just install on one server. You're good to go after that. Then what you need to do is set up and configure the database cluster on primary server, or the primary database cluster needs to be configured. Once that is done, you can use PG based backup to get a backup, and you will need to ensure that archiving is in place if you are using PG based backup, so that any WAL files which are generated during the backup process are also available when you start up the replica. Now in this server, I have a virtual machine, and that virtual machine's IP address is what you see on your screen over here, 192.168.160.155, and it has a data directory. I'm using Enterprise DB's installation of Postgres Plus, but the features that we are going to cover pretty much apply to the open source PostgreSQL as well. So you can try it out with PostgreSQL open source community version as well. and they should just work the same way as I'm going to describe today over here. So the data directory that I have chosen is inside OPT Postgres Plus 9.3 AS data, and port number is 5445. On the very same server, I have one more database instance or cluster, and that is inside data 2, and the port number is 5446. The parameters which you will require to change on the master database are these: the wall level, which basically defines what is the level of information which will get stored inside wall files. So by default, this value is minimal, which means that it is minimum only for crash recovery. The information which gets logged here is applicable or useful only for crash recovery. But for more complicated recoveries, for recovering from a backup or a disk failure by restoring a backup, for those scenarios, or if you want to roll forward, for those cases you need to set it up to archive. Or if you want to add even more information so that standby servers can be used for read purpose, you need to set it to hot standby. In hot standby mode, even more verbose information or more detailed information is logged about transactions and operations inside the wall files. That is why you have to set it to hot standby here, because the second replica we are going to run in hot standby mode. That is why we need to set it as hot standby. Max wall senders. Now this parameter has been introduced in 9.0 along with the streaming replication concept. This parameter decides basically how many wall sender processes are running on your master database. These wall sender processes are necessary, and these processes are responsible for sending the wall records across to the standby server. So we have kept this to be 3, but you can ideally keep it to be any positive integer. Set them to be as many as standby servers you are going to have, so that you don't have to run out of these processes. Otherwise, if you change this process, you have to do a restart. This cannot be changed on the fly. Same applies to wall level as well. You need to do a restart if you're changing that, because these are basically changes in the core. These are not changeable on the fly. Wall keep segment. Another parameter which you need to set for streaming replication. Now we have set it to be 128, which means that at least 128 wall segments will be kept live. They will not be recycled or they will not be archived. So this means basically that my database server, PostgreSQL database server, is always going to keep 128 walls live. This parameter depends on your load, and this ensures that wall files are not removed from your live wall location before being applied on the secondary servers. So this is a very important parameter, and if you don't set this optimally, or if you don't set this wisely, your secondary server or your standby server might go out of sync, and then you have to rebuild it. So set this properly, and this will depend on the load on your transaction volumes. Then you can set replication timeout, which is an optional parameter. Replication timeout basically would time out the replication process if the slave are not available for that much amount of time. So I've set it to be 5 seconds, but this is optional. You can skip this parameter. Then you need to set hot standby to be on. Now this is basically not required as such. You don't really need to set this on the master, but I do change this on the master itself, because this parameter is not going to be effective for the master at all. This parameter is effective only when your server is running in hot standby or standby mode. So you can just set this on master. Now the advantage is when the backup is taken to my secondary servers, at that time this parameter will also get copied. So the manual steps of editing this parameter on standby server is reduced. So that is why I prefer changing it on the master itself. Then synchronous standby names. This is basically a comma separated value, and I can specify multiple slaves here. These are basically the name that you see there. HA cluster is actually a designation for one of my slaves, and if I have multiple slaves, I can add a comma separated value here, HA cluster 1, comma HA cluster 2, comma HA cluster 3, and so on. This basically ensures that HA cluster 1 will synchronously receive all the changes happening on the master. So if I change anything, it will propagate to HA cluster. And if I have multiple values here, then it will first try to replicate it to the first server. If the first server is not available for some reason, it will go to the second server. If second server is not available, it will go to third server. So this basically ensures that changes happening on master are synchronous. In addition to this, you also need to set synchronous commit to on, but by default that parameter is always on unless you switch it off. So I have just skipped that parameter here in this description. Then you need to add a pghba.conf entry. So basically, since we are going to add a new standby connection, this standby server is going to connect to your primary server and pull wall records, right? So to enable it to connect to the primary server, you need to add an entry in HBA configuration. So that entry would read something like what you see on my screen. The entry type is host. Database name is replication. This is a special database name which has been reserved for replication connections, and you cannot use it for other databases. So even if you have a entry called all, still you need to add this entry. This is specifically for replication connections, so you must add this. Then you need to add the username, the IP address from where it is going to connect, and you need to add the authentication type. I have kept it to be trust, which you can do if you trust that server, and you have restricted the user to be replication only user, then you can do this very well. And you can also restrict the number of connections from that user, and you can keep it to be 1, and you can allow only one server to connect to using that user. So you can use it, you can use trust to be the authentication method in those cases with those considerations, and that is what I have done actually. And I'm gonna use trust because I don't want to use my password in plain text, or I don't want to keep it in pgpass file, so I have kept it to be trust. Now let's see what other steps will be required. So the other steps are going to be taking a backup of the primary instance. So for that I can use pg-based backup, and then I'm going to restore it on the secondary server. So I can use pg-based backup, and pg-based backup can help me to take backup of a remote database as well. Now pg-based backup again works on the same streaming protocol, and this great tool also came up after the streaming replication. And once the backup has been taken, I can restore it. And even if you're using pg-based backup for taking backups, you are going to need a replication entry over here in pghba. So you need, even if you're using pg-based backup from another server, let's say from 56, then still you will need that entry. So this entry of replication in pghba is not needed just for replication, but even for pg-based backup as well. This tool was introduced in version 9.2. Now once you have taken the backup, you can change the port number. Now I'll tell you how I do this and how I manage these different configurations more efficiently when I do the demo. At that time I'll explain you. Then you need to create a recovery.conf in which you need to set the standby mode to be on. So hot standby mode should be on. This is a mandatory parameter in recovery.conf. You need to specify the primary connection info, primary con info. So this is basically the entry which connects your standby server to your secondary to your primary server. And using this host name, port number, username, it is going to connect to your primary server. Now you see here I have specified an application name. This application name exactly matches with the synchronous standby names. If you remember, it was HA cluster, right? So let us review those parameters. So see here on this slide, it is HA cluster. So that is the same value that we have specified here, and that same value is going to be specified in any other standby server if you want, or if you have configured multiple application names or different application names, keep them in a comma separated value. Then we need to specify recovery target timeline. You can skip this parameter, but I'll keep this parameter because this is required for rebuilding and remastering. Then you can specify a trigger file. This trigger file is basically used for doing the failover or promoting the secondary server to become master. Once this trigger file is detected, secondary server will promote itself to become master. So this is an optional parameter. You can skip this. There is another way how you can promote a secondary server. We'll look at that as well. Then once this is done, you can start your secondary server first. Once your secondary server has been started, you will see that there are some warnings in your log file. These warnings can be ignored because these are basically telling you that the primary server is not available since we have never started it. But I'm still going to start my secondary server first. The reason is I don't want my secondary server to lose any transactions on primary server. So first I start up secondary server and then I start my primary server. As soon as I start my primary server, any transactions I do there will be replicated to the secondary server. This is how we can test the replication. You can insert some data on the primary. You can select that data. You can select that data on secondary as well. It should return you same number of rows as on primary. Then you can check if you try to insert on secondary server, it will throw you errors which will say that you can only execute read-only queries on secondary. Now let us try to do this. So let's try to do this. So I'm now connected to my virtual machine, and on this virtual machine I'm going to show you how you can take a backup and how you can set up your master and slave databases. Sorry about that that pop-up. Yeah, so let us go to pg data, configured pg data, which is basically for my data directory. So directory, so I open my postgresql.conf file for you. So in my postgresql.conf, you see that I have used include directives to specify that there are some additional configurations which are available in streaming.conf and port.conf. So to make my life easier, I always do this so that these extra parameters are read from these additional files. So in streaming.conf, I have set these parameters: wall level hot standby equal to on, max wall center 3, and wall keep segment. Since this is a small server, I'm going to keep it 32. Then let me open port.conf. So port.conf is 5445. Now I'll go a level up. I'm at this directory and I'm going to create a data2 directory here. You can skip this. You need not always create this data2 directory here. It is not required all the time, but I'm just going to create it just to show you that the data is going to be coming over here. The backup will be stored into data2. So I'll use pgbase backup -u, my database user. Before this, I need to ensure that something which I forgot is I need to ensure that my PGHBA has proper entries. So I'm gonna go to PGData again. Sorry for that, I forgot it completely. So if you look at it, you will see that the replication entry is already present with trust mechanism as the authentication method, right? And the database name is replication, the username is enterprise DB, the IP address is the local IP address. So I'm going to go up and I'm going to say PG base backup -u enterprise DB -h. These are all same options like PSQL 192.168.160.155, my server IP address, my port number of the database. So this will try to stream the backup from this server and store it in the directory which I'll specify by -d, capital D option. I'll also say -r so that it also creates a default recovery.conf file, which makes my life easier, which makes the steps faster. Now the problem here is max wall senders is currently 0. So this is a very typical error that you will receive if you have not configured your max wall senders. So let us see. In streaming dots, I have max wall senders. I think I just need to restart my database. So if you have changed max wall senders, you need to restart your database. And probably I had not restarted it after changing it last time, and that is why this was not effective. So let us try it out. So you see it is going on now. It didn't prompt me for a password because the authentication method was set to be trust. Let this complete. Let's wait for a while. Let the backup finish. So meanwhile the backup finishes, let us resume our discussion on replication and failover. So once you have set up the failover, once you have set up the replication and it is already going on, you can actually set up the you can trigger a failover by either creating the file. So if you remember, in recovery.conf we discussed about some files. If you remember, in our recovery.conf parameters, we had a trigger file. And this trigger file can be created to start or to initiate a switchover. But before you do a switchover, you should always stop your primary database. Now, you could, instead of running into a switchover scenario, you could actually run into a failover scenario. In those what happens in those failovers is your primary server dies. Your primary server gets killed because of some reason. It is like pgctl stop immediate or kill the PostgreSQL service using kill command. So in those cases, you can either create this file on the secondary server and promote it, or you can fire a command called PGCTL promote. So when you do PGCTL promote, your secondary server becomes primary server. Now you can automate this whole thing by using shell scripting. Simple shell scripting. Use this shell script to connect to the primary server, and if this primary server goes down, just go ahead and create the trigger file or do PGCTL promote on your secondary server. As simple as that. Quite easily configurable, quite easily done. It is not very complicated to be achieved, but sometimes it gives you some troubles, and in those scenarios, to ease this whole process of auto failover or automating the failover, you can use standard clustering tools like Enterprise DB's failover manager, or you can use pgpool as well. Pgpool also works pretty well in those cases, but Enterprise DB failover manager is quite good. You can use that to automate this whole failover process. Now, once this completes, the failover completes, or once your secondary server is promoted to be primary, the recovery.conf will be automatically converted to recovery.done. Here is a typo here. It is actually recovery.done. Now, when it changes, why does it change to recovery.done? It changes to recovery.done so that you don't run into a recovery next time when you restart your database. That is why the file is renamed. Now, you can connect to the secondary server and you can test it. You will be able to test it either by trying to do some write transaction, or you can use PG is in recovery, which should be false, which means that your this server, current server to which you are connected, is not in the recovery mode. And then you can shift your application, or if you don't want it to be known to your application, then just your virtual IP to the new database server. Switchovers are much more smoother because you would know about them. Like I said earlier, failovers are not known to you. It is very abrupt shutdown of your primary database. It is either because of power failure, disk failure. There could be multiple reasons. Switchovers are control scenarios which you would generally do to apply patches, OS patches, database patches. So when you do switchover, first thing you should disconnect everything from the primary node. Do a PGCTL fast or smart to flush out everything, to send all the pending walls to the secondary, and then you do a PGCTL promote on secondary. And once this has been completed, the PGCTL promotion is completed, you can actually copy, or you can create a new recovery.conf file on primary server, which was your old primary. And on this old primary, once you have created recovery.conf, you can start it up as a secondary server. Now, same thing that you can do for testing your new primary server, you can do it over here as well. Now, how can you handle multiple replicas? We'll discuss that, but before we discuss that, let us go here and check. Yes, our backup has completed, and let us go to data 2. So inside data 2, you see there is a file called recovery.conf. So let us open recovery.conf. In this, you will see that there are certain values set already. Username, host name, port number, all those things are already set. So let us add some more parameter like recovery target. Okay. What else do we need here? Let us go back and check. I think these parameters should be good enough. Let me check if I have missed anything. I just want to be sure, because I don't want to do this again. So trigger file is something that we can skip definitely. We have not missed anything. Trigger file can be missed. We can miss trigger file. We can afford to miss trigger files, because if you don't have trigger files, you can still promote using pgctl promote. ctl -d Postgres plus 9.3 AS, and what I'm going to do is I'm going to specify data2 this time. I'm going to say start. So I'm starting up my secondary server. So let us create a new table integer on the primary database, and I believe there has been some issues in the database creation, in the database backup. You change some parameters. What I can do is rather I can remove the files, backup again. Meanwhile, let us go back to our discussion. Now, what is remastering? Remastering is about creating a slave as a master or promoting a slave as a master, and other slaves should point to this new master. That is remastering. Now, as I discussed, 9.3 timeline switches are part of your wall logs or wall records. So timeline switches, which can happen during point-in-time recovery or when a replica becomes master, all that information is now going to be part of wall, so it will be replicated, and hence you can point a old slave which was pointing to a master to a new master. Now, what does that mean? See, server 1 replicates to server 2 and server 3, but if server 1 goes down, all I need to do is restart my server 3 by pointing it to server 2. As simple as that. And the replication will be rebuilt, and there is no need to restore the archives or rebuild the server 3 from server 2. It is just as simple. Now, if you want to rebuild your master database, you do not have to take the whole backup again. Okay, you don't have to take a backup of your master database. You don't even need the wall archives of the lost primary database. All you need to do is set up recovery.conf, and then this recovery.conf should be pointing to the new master or the secondary database, which was the old secondary database, which is now master. And once you start this old master, it will be secondary now. Okay, but just remember that since your master has gone down, whatever walls are generated should be present on your secondary database or on the new master. If they have been removed or archived, then you cannot restart or rebuild your master directly or without going through the pain of restoring a backup from new master. So you must have all the wall files. To ensure this, you can either set up archiving, or you can set the wall keep segment to be high enough. Now these are the functions that you can use for monitoring your replication progress. PG is in recovery will tell you whether a node is a master or a slave. And transaction ID current snapshot, TX ID current snapshot will tell you what is the current snapshot on master. Or if you run it on slave, it will tell you the current snapshot on slave. So this basically helps you monitor the replication progress. You can get latest information about replication from this view called PG stat replication. Now, let me go back and see the backup has been completed, and I hope this time it will be less of a hassle. So first is I'll change this value. Like I said, removing it or moving these kind of parameters into distributed files helps me go and modify them faster. So it becomes much more easier for me to modify it. All I need to do is, I could have also said echo port equal to whatever value I want to put here and the file name. So I can do this programmatically as well in a shell script. Well, we are not doing it here. Streaming.conf, I can just leave it as it is, no changes required. pwd is data2, so you see that this is my new data directory. Oh, sorry, pgctl start -d, and then the data directory name, and it should start. PSQL and try to connect to the port that we specified. If you remember, this is the port that we had specified in PostgreSQL.port.conf. Prompts me for a password, which means that it is going through. So let's select is in recovery. It says true. Let us open a duplicate session of the same server. So what I'm going to do is I'm going to open two sessions here to show you the recovery. It's just a bit typical of my clicking habits, which is making it maximized. Yeah. Okay. So this is my primary server. PSQL-P 5445 is the port number. I connect here. I select and I select and it will give me false. Here it gives me true. Now let's create a database, a new table here. Create table. Table has been created. Just 10. Application. Now let us fire the same command on the standby database. Wow, as easy as that. See, the replication has been set up. Whatever changes you do here, replicated here as well. So you insert one more value, let's say 11, and you check it out here. Wow. Then let us try to insert something over here. On the secondary database. So I'll say so you see the error, cannot execute insert in a read-only transaction, which means the slave is right now read-only. You need to promote it to be a master. So let us do that. Let us get pgctl opt an immediate stop of my database server, of my primary database server. Sorry, a fast shutdown of my primary database server. I forgot the start keyword here. So once I do this, sorry, I did actually no, but I have to keep this font large, and that is why I have kept this huge size. So this shutdown is actually waiting for all those walls to be replicated, which now got replicated. You'll notice that the moment the primary server has been stopped is not the moment secondary server becomes primary. See, still secondary server is read-only because it is still not primary. Is in recovery, it is still true. See that? It is still in recovery mode, waiting for more wall files. Okay, now what we need to do is pgctl -d Postgres plus, and I'm just specifying the path to be data2, and I'm going to say promote. Server has been promoted. Now the recovery mode is false. The server is no more in recovery mode. I can try to insert some value. Wow, it goes through. So the switchover is as easy as that, isn't it? This is how easy the switchover is. And now you can select from the file, from this table as well. It is going through. What I'm going to do is I'm going to go to server 1, and I'm going to make of recovery.done as recovery.conf inside data. So here additionally I also need to say that recovery target equal to latest, then I need to change the port number as well over here for the standby, and my primary is going to become secondary. So primary will connect to the new primary, or the new secondary will, rather the correct thing is new secondary is going to connect to new primary. So here I need to specify port number of new primary. Path and start. problem here is about PostgreSQL.conf. Let us see where we are. Okay, let us level inside some folder. That is why it didn't start. Yeah, it started off now. It takes me here. The PG is in recovery is true here now. See, now I'm connected to the old primary, which has become now secondary. Over here, it is still the same. If you remember, while my primary was down, I inserted certain values. Let us see if those values are still present or not. So those values have got replicated. Anything which I did during the failure period or the outage period have been replicated. And for this to happen, it is very important that you must have large enough wall keep segment so that those wall files are kept live once your primary server goes down. Let us insert a new data here. So I inserted a new value here, 13. And let us select. So you see 13 has been replicated to primary. As easy as that. So adding the primary or the lost primary back to the cluster has been made quite simple. Earlier you had to rebuild this whole thing just for that. Now is as easy as that, isn't it? So let us try to see the replication progress. So for that I need to go to my primary database, which is now this. So select star from pg stat. See, this is going to be a huge data, so what I'm going to do is I'm going to put my PostgreSQL in expanded mode, in my PSQL in expanded mode. Okay, so here it is. The replication is happening to a wall receiver which is running on the same server. It is using this port number. The backend or the database server started at this time, and it is currently streaming data or the transactions. This is the sent location, this is the applied location, which means that it is in sync right now. This is the flush location, this is the replay location. The mode is asynchronous. To make it synchronous, what I can do is I have to just change the standby names, the synchronous standby names on my primary database, and I have to add a parameter or a value in the primary coninfo on my secondary database. That's all. It's as simple as that. So I hope you guys have learned something from our discussion today, and the demo would be useful to you even when you watch it again or you replay it. The slides are going to be uploaded on our SlideShare site, on our SlideShare account, so you can go and download the slides, and you can pretty much follow all the instructions step by step. You can even copy the configuration files other than the IP address, obviously, and you can try to do this in your own labs or on your own laptops. And if you have any questions, please drop us a note, put it in the comments on YouTube or on our website. Put it as a comment. We will get back and reply to you. Thanks a lot. This was Samir talking on behalf of Ashnik and sharing whatever we have learned from our Postgres experiences. You are welcome to come out and share your own PostgreSQL experiences or any tips and tricks that you want to share with the world and become a PostgreSQL hero. Thanks a lot.